Okay, let's start. Hey everyone, this is Charlie, the co-founder and principal of XCamp and X School. So we're here to support as a pre-contest Python workshop for the Harvard GWISE Art of Programming contest. Welcome to this workshop. Next slide, please. Yeah, this context is.
Hi everyone.
Yeah, it's Kiwi. Yeah, to share about this context. Yes, go ahead, Kiwi.
Yep. Sorry, Charlie. I got too excited. Hey everyone. Thank you so much for coming to our pre-contest Python workshop. It's so great to meet all of you guys, even through the screen. And we're so excited to have you here. So I'm Kiwi Florido. I am a PhD student at Harvard University, and I am also the president of the Graduate Women in Science and Engineering. And so my student group actually hosts or helps scientists along the way throughout their graduate studies. And hopefully one day we'll see some of you guys become scientists and become future coders through, with the help of programs like this one. So we're really excited to actually team up with Charlie and his team at X School to be able to cultivate young coders just like you all from grades 5 to 8. And we're excited to host this year's contest with a theme of the kindness quest. And so this is one of many programming contests that we hope to host. So hopefully this one is successful and we hope that everyone has fun. So I do want to take some time to thank Charlie and Mandy for making this event happen, making this program happen. But I also want to thank our instructors who are here with us tonight. And for everyone along the way to help make this program really successful. So I want everyone here to know that this contest is about using technology for good. So our theme this year is called the Kindness Quest. So we made this so that it will challenge you to create projects that spread kindness, whether that's helping someone learn, cheering someone up, or making the world just a little brighter in your own way. You can do this by programming games, stories, animations, quizzes, arts. It's really whatever you guys want. So we want you guys to show us where your imagination takes you. So over the next part of the event, Charlie and the rest of the team will give you all of the information that you might need for our programming, and you can email us if you have any questions at all. You can also have your guardians email us if you wish. And we're so excited that you're here, but we cannot wait to see the final products of everything that you achieve. So we are so excited. Thank you, Charlie.
Thank you, Kiwi from Harvard. Thank you for organize this contest. I think this will be a very good opportunity for the students to demo their mastery on coding, especially the creativity on this art programming, especially on the topic, the kindness. Okay, here are the key dates. Kiwi, do you want to announce the key dates, or I like to say that? I think it's good for you to announce the key dates. Yeah. Kiwi?
Yeah, I can do it. So I think everyone is if you want this is going to be recorded, but you want to make sure that you maybe print this out. So registration has already opened, but we extended the registration to August 30th at 11:59 a.m. Pacific time or California time or whatever time zone you're in. You just need to match that. Our free training will take place today, so where you guys are all at, to August 16th, and both times are going to be from 5 to 7 p.m. So this is an optional free training that X School is hosting for you all. So if you're already expert Python coders, feel free to skip it, but I think you will definitely learn something from our instructors. And so we also have the round 1 of submission from all of you, which is going to take place from August 18th to August 30th. And then we are going to announce the results from the evaluation from the judges that we have from Harvard, MIT, and expert coders from different companies. And that's going to be in September 6th. So remember that you definitely need to be on the lookout for that to see if you make it to the final round. And so our final round submission is basically the second part to this hackathon or to this programming contest. And that is going to happen from September 6th to September 12th. And then we are all going to have a live final presentation from those of you who make it to the final round. And you're going to face some question and answers portion from the judges that we have. So you can explain to us exactly what you programmed, why you programmed what you programmed, and tell us a little bit about your game or your animation. And then we will then announce the final results in September 14th. So if you have any questions on the deadlines, please email us early. Mandy is going to be your point person. And again, you can email her anytime. Thanks, Charlie.
Thank you, Kiwi. Yes, students, we have about 15 more days to do the first round submission. Yeah, after that, if you get into the final round, you have another week to prepare for that. And final submission is September 12th. Yeah, it's another 12 days. Yeah, thank you, Kiwi. Yeah, let's go to the next slide. Okay, yeah, here's the awards. So for the round 1, we have top 4 teams per grade. We have grade from 5, 6, 7, 8. We have 4 grades. So which grade we have 4 teams, we are advanced to next round. So the final round, we have 3 awards. One is most creative project. Second one is most technically complex. The third one is best social impact. Also for all the winners, so we have a $50 Amazon gift card. Also, we have $100 XCAM course coupon. This is for new students only. Also, we will have a certificate from Harvard, GWISE, and X School. Next, please. In addition, for all of you who attend this contest, you will have live raffle prize. The first one, we will have MacBook Air. We will provide a MacBook. I think some of you would like to have your maybe first computer. So all of you have the opportunity to get the raffle. Also, we have 2 AirPods Pro 2. If you, I think some of you might like this too. Finally, also we have 5 XCAM $100 cost coupon for the raffle too. Yes, for the last day, even you are not advanced to the final round, but you are welcome. I think you should join the final round and get these raffle prizes. Okay, there are some rules about the raffles. I might not, do all the details. So everyone have eligible. Also, you need to participate, and each participator will have a unique ID. We will assign you before the final round live judge. So we will do the raffle during that time. So everyone have the equal opportunity. We are randomly chosen, and the winners will be present. On the final day, you need to be there to claim your prize. If you're not there, you got the raffle, but we will skip you. Maybe go to the next person who is present. Okay, great. So I think this will be 2-round fun and challenge. Yes, next, please. For today's workshop, we will learn Python language fundamentals. So our very welcome popular teacher, Brandon, will show you the Python drawing tools. And the second class tomorrow, he will show you the animation tools. Also tomorrow, he will show you how to design a project and how to develop a project, all the tips on that. Okay, great. Let's go to next slide. So I think that's all me and Kiwi want to share. Kiwi, do you have anything else to add if I turn to teacher Brandon?
No, I think thank you again, everybody, and we really hope you have so much fun. And Teacher Brendan is here to answer any and all of your questions. He is an expert coder, so you all need to take advantage because the session is free, and we cannot wait for your projects and what you all come up with. Thanks, everyone.
Thank you, Kiwi. Yes, we have a TA, Delin. He's here. If during teacher teaching, if you have any technical questions or issues, the teacher might not, the teacher will go through the teaching slides and materials. The teacher might not have time to help you, but our TA Delin, he will help you if like how to run your program, you have some issues, and Pin Delin, he will maybe go to the rest recovery rooms to help you here. Okay, thank you all. Yeah, thank you, Kiwi, again. Also, thank you, Mandy, to organize this. I will turn the class to teacher Brandon. Good luck with your contest.
Okay, thank you, Charlie. And actually, before I get started, I think that there's a student who has a question. Aaron, before we get started, do you have a question is it for myself or Charlie?
Is round one going to take place somewhere, or is it just online submission?
Submissions happen.
Yeah, it will be online submission.
And for the presentation, if we make it to the final round, will we have to go somewhere to explain like our project?
Yes, and it will also be online, and it will happen on September the 30th. So yeah, I think all of the things can be found in FAQs, but we will also send out detailed instructions later on.
Okay, thank you.
No problem.
Okay, any other questions? All right. If not, I will get started. So first things first, I want to introduce myself. My name is Teacher Brendan, and I'm a teacher at XCamp. I'm currently located in California in the Bay Area. That's where our headquarters is. I think we have a lot of students who are all over the country, right? Anyone from the East Coast? Yeah, a couple of students. And I think we have some students as well who are in the West Coast as well too, and some XCamp students too. So today I'm going to be your teacher. Actually, today and tomorrow I'm going to be your teacher for these two sessions. And the idea of these sessions, like Kiwi mentioned, was to help you get a jump start with your project. Okay, so when I'm talking about helping you get a jump start in your project, that doesn't mean that I will be sitting side by side with you, helping you to write the code, and if you encounter a bug, helping you to fix that. Unfortunately, there's just one of me, and there are many of you, and I won't have the opportunity to do that. These sessions will be some training. So as Charlie mentioned, what I'll do is I'll spend some time today going over some of the basics of Python, going over some of the basics of how we can do some drawing and things like that. And then tomorrow we'll focus on how we could potentially add some animation or movement to our project, and then also some interaction into our project in that way. So that's the stuff that I'm going to be covering along the way. There will be some interaction. You definitely can ask questions and participate in the little coding challenges that we do. I really, really recommend that, especially if you're a beginner and this is new to you. If you're already experienced with coding and this is a little bit easy for you, feel free to tune me out and kind of work on some ideas. And when I bring up some stuff that's new to you or interesting or might help you with your project, then you can kind of jump back in and follow along with us. So everyone here today will have a different level of coding expertise. So some of us are very, very beginning, and maybe we're going to learn our very first lines of Python code today, or maybe you already have some experience writing code, and that's really great. And so just to be clear, I will be starting from the beginning and sort of building up for those students who are very entry level. And so if it's a little easy for you, just be patient. You could always work on your project in the side while I'm teaching towards those who are beginners. Okay. All right, so that being said, two more things that I want to mention, which is how will we operate the online classroom? So right now we're in the online Zoom classroom, And we need to have some rules in place, which is, we need to be respectful with our communication. So just make sure if you have something to say, if you would like to answer a question or comment on something, just make sure that you raise your hand in Zoom. So let's quickly do a little exercise to make sure that everyone knows how to do that. Can you go to the reactions button at the bottom and just click the hand raise to show me that you know how to raise your hand? See if we can get all the students to do that.
Teacher,
Yes?
I need to leave at 6 because I have things to do.
Okay, yeah, no problem. Okay, great. All right, and then just if you could now just lower your hand. So after I've called on you, then you can lower your hand, just like that. Okay, and the rest of the time we have lots of students, so just make sure to stay muted in case there's any background noises or things like that. And so everyone can hear me clearly and see what I'm talking about, and we don't have any distractions like that. When I call on you, that's your opportunity to unmute yourself, okay? Additionally, as Charlie mentioned, we have a teaching assistant, a TA, who's going to help us here today. So our TA Dylan is here to help you out. If there's any point of time during the lesson that you're stuck on something and then you need a little bit of help, maybe you didn't get to set up a coding environment yet where you're going to write your code, and you'll see me sort of just jump into that right away. That would be a great opportunity to reach out to Dylan and ask him if you can go to the breakout room to get some help. Or if you're stuck on one of the exercises we're doing or something like that, another great opportunity. So just make sure that you send a private message to him, asking him for some help or asking if you can go to the breakout room for a question. If you're sending me messages, I'm doing my very best to read the messages. It's a little bit challenging as I'm teaching and then kind of reading on the side. So for the most part, if you want to get my attention, just make sure to raise your hand in Zoom, and that's the best way for me to call on you. Okay? If you need help and you want to get some debugging help or some setup or not quite understanding what's going on, then just please make sure to send a message to Dylan. Okay? All right, so I suppose that's everything we need to know. So before we get started on our content for today, let's see if we have any questions from students. I'm not quite sure if people just forgot to put their hand down or if they still have questions, so I'll call on students one by one. Oscar, do you have Oscar put his hand down. How about, I guess everyone's putting their hands down one by one. Okay, I guess we could get started then for today. So I'm going to share my screen. And let's get started. So first things first, welcome to the class. This is a preparation class, like I mentioned, for the project that you guys are all going to do. And the theme of this is this idea of kindness quest. And it's a really nice theme because there's a lot of different directions that you can go with this project. And so, today and tomorrow, we're just going to build a really strong foundation and give you a lot of different ideas of ways in which you can go with your project, and just sort of help you to get thinking of ways in which you can integrate some of these things into your project. So I think the best thing to do when we're about to start a new project and we're kind of unsure about what route we want to go down and all that kind of stuff, or even if you're a beginner to coding and you're not even quite sure what you can and can't do, a really great place to start is just to do a little bit of brainstorming and sort of start talking about the ways in which we see technology in the world and what are the types of problems that we would want to solve or make our life easier in specific ways. So what I have on the screen are a couple examples here, a couple of little emojis for us to just kind of start thinking about where we see code in the real life. Okay, so does anyone want to jump in and help me out and maybe say, hey, this is one of these emojis, maybe this is what it has to do with coding? Yeah, Changin, would you like to share?
Oh, so the first one is applications, and then we've got games, art. Most notable ones are procedural art, and I'm not really sure what the helicopter is.
Okay, yeah, then maybe that one's a little bit more abstract. We'll see. So you're very right. So the first one is it's a mobile device. It's a tablet or phone or whatever you want to envision this emoji to be. But think about things like Instagram or TikTok or games or all those kind of applications that you have on mobile devices that we often interact with on a regular basis, sometimes even on a daily basis, right? Those applications were built by developers who wrote code in order to create instructions on when you're playing this game, what should happen, or when you click on the add to cart item in your application that's for some online shopping, right? What should happen in that moment? How does it move the product from into your shopping cart? Like those little things, those are created with code. So a lot of times those are things that we do on a regular basis, and we don't really think about that we're interacting with some code that someone wrote, because all we see is the visualization or the display from it, not the actual code that's happening behind the scenes to make sure that everything works. Okay, and let's go to that next one. Yeah, maybe it's a little bit more abstract. Um, this emoji is like a little helicopter. I'm looking at it as like a little drone, a little robot, something like that. And here's another example of where we can find code, which is, like things like delivery drones or Mars rovers, or I'm not sure how many students have ever participated in robotics or things like that. A lot of times my XCamp students are interested in that kind of stuff. And that is involved with coding, right? So if your robot needs to move or avoid some obstacle when it's in its way or jump or something like that, right? That would be some instructions that you've created for a situation and how the robot should resolve that situation. So that's it's coding, right? Coding helps us to control those machines that we create. All right, how about that next one? I think we already mentioned it. So video games. So yeah, like the mobile games, or maybe you play games on the computer, or maybe you have some sort of gaming device like a Switch or something like that. All these games are written with code, right? Some developers, they wrote the instructions on what should happen when a character is moving around the screen, when you click the X button or the Y button, what should happen in those moments, right? When your character, maybe your character is running out of lives and then the game ends, right? Someone had to write some instructions for that to happen. And that's where code is involved. And finally, this last one is about art. So when we're thinking about like digital art or animations or things like that, graphics, interactive stories, kind of touching on some of the things that Kiwa is saying about that, what you could do with your project, another example as well, right? So how can we sort of use coding in order to create some art or graphics or interactive designs? There's lots of examples in the real world, and actually we're going to be doing some of this today. We're going to be doing some graphic drawing today to give you some help on your project. Okay, so if you haven't written your first line of Python code, well, actually we can get started on that very quickly. So what I'm going to do is I'm going to bring up my coding environment. Okay, so my coding environment is this application here. It's called Thonny. Okay, in XCamp we like to use this coding editor called Thonny because it's very simple and easy to use in order to start writing my first lines of Python code. It doesn't have all these buttons or fancy configuration. It just has the simple things in order for me to write some code and then to see what's going on. And so if we see this sort of shell window at the bottom, we're going to see some text or some information pop up as I'm writing my code. And so this is a really nice beginner-friendly coding environment. Now there's other ones that you may already have set up or that you're familiar with. Maybe you have an online one like Replit, or maybe you've heard about like VS Code and you already have that set up. It's really up to you to figure out what's the coding environment that's best for you. However, for us in XCamp, we often recommend the students start by using Thani because it's simple and easy to use. So if you're curious about what I'm writing my code in today, this is a coding environment called Thani, which you can download as well. If you have some questions about it, feel free to ask that to Dylan, who can send you the link to the download or help you set up if you get stuck. Okay. All right. So let's go ahead and write our very first line of Python code. So I'm gonna follow the slides here, and it's telling me to write this piece here, which says print welcome to the kindness quest. Okay, so I cheated. I copy and pasted, made my life a little bit easier. And so I have exactly as the slides say, print, and then welcome to kindness quest with some quotation marks. And for me in my Thani editor, the way that I will run my program is I will hit this green play button. So run, okay? And when that happens, what I'll notice at the bottom is I'll have this text appear at the bottom, and it's saying that I'm running my file. So I have this file that I created for this Python file for in class today, and showing me this text that says "Welcome to Kindness Quest." And what we'll notice, the observation that we make is that it's the exact same text that I wrote. Okay, so for example, I can change this text. So let's go to the next one here. This one says, "Let's make the world a better place with code." Okay, so if I copy this one here, and I put that one instead, and I run my code, I get that text here, and I can say, "Let's make the world a better place with code." So, like I said, the observation that we make is whatever text that we're putting into these quotation marks in this print, this is something that we call function. I'll get into that a little bit later. It appears on the screen, so that's pretty cool. So I can just sort of write whatever text I want to, and then it appears at the bottom. Now, one thing that we have to be very, very careful about when we're learning to code, and this is something it takes a little bit of time to adjust to, is that when you're writing code, the machine has a difficult time understanding what you mean. So if we're not very precise, okay, I'll give you an example here. If we're not very precise, the computer won't understand us, our Python program won't be able to understand us, and we may get an error. So here's an example here. What I've done is I've changed that print from a lowercase p to uppercase p. And you might tell me, "Oh, Teacher Brendan, that makes sense. What you're trying to do is you're trying to print some text to the screen." But when I run my program, Python complains. And Python says, "Hey, you tried to print out this gibberish text here, and print," it says print with a capital P is not defined. So this is an instance of a realization that we have to be very precise with our program, and that little mistakes like this are what could get you stuck and will get you stuck definitely in the beginning until we sort of train our brain to be very precise in specific ways in order to write this Python code. So that's something that we'll need to adjust to. Here's another example here. Let's say, for example, I left out the quotation marks, and then I run my program here. So this one is saying, "Hey, name error, this text here is not defined." So it doesn't understand what this text is. The reason is because it thinks it's some variable, not some string. We'll talk about that in a couple slides. But again, precision is very, very important, and detail-oriented is really, really critical when we're learning to write Python code or just writing code in general. Okay. So that's how we can make Python write some text to that console window at the bottom, to that shell. And then how can we give our program some information? So it's nice to be able to write a bunch of text and show the user some text that we've written, but we also want to be able to have the user interact with our program. And in order for our program to interact with some information from the user, we have to collect some input. And so the way in which we can do that is with this input function, okay? And so if I copy this example here, what I'm doing here is, let me get rid of this guy, is I'm telling the Python program, hey, I want to collect some information from the user. And specifically, when I ask them for that information, I'm going to say to them, hey, what's your name, kind friend? Okay, so I'm going to tell them that. And then what's going to happen, you'll see, is I'll run my program. And what you're going to see is I get this sort of blinking cursor. It's waiting for me, the user, to enter some information to my program. Okay, so I can enter some information here. What's my name? My name is Brendan. And I hit return because I want to send my information to the computer program, and nothing happens, right? So this information was collected by my program in this value here called name, which we'll talk about in a second, something that we call a variable. However, we didn't do anything, right? So it's really up to me now to do something with that information that I collected from the user. And so let's try this line here. What we're going to do is we're going to write this next line of code, which I'm going to use that print function, just how we talked about, and I'm going to use the name that we collected, and I'm going to say hello, and I'm going to plug in that name here, and I'm going to say ready to spread some kindness. Okay, so let's watch this again. When I hit the play button, it says, what's your name, kind friend? I can enter my name here. And then when I hit the return button to send the information to the program, now it's going to go to line 2, and it's going to combine that input along with the other text that I wrote. Okay, it's going to say, hello, Brendan, ready to spread kindness? And let's try it again. Let's try it with a different name. Hello, and I'll write my gibberish, my key smash here. And there it is. You can see how it gets inputted into my program just like that. So now we have two really critical things that we can use in our Python program, which is to send some information to a user in the form of some text, right? We can write some text here. And as well, we can interact with the user to collect some information from them. So this is already, even just these two lines of Python code that we've written, we already have a lot of functionality that we can use within our program. Okay, so if you're new to Python programming or programming in general, when you're looking at this, this may look a little bit strange. Okay, so you're probably saying to me, if you're new, hey, Teacher Brendan, what's this part here? This name equals, what's going on here? What's this? A valid question, which we'll make sure to answer. And then this one looks really funny, which is, look how I had some text, and then I'm using the plus button with that name, and then another plus. And you might say to me, well, Teacher Brendan, plus is used in math class. That's when we want to do like, hey, 4 plus 6. But here we're not using it with some numbers, right? We're using this plus with some text, some text information. What's going on there? And so, what's going on is that there's some functionalities in Python that we will get to learn along the way in this class. And one of these functionalities that we're seeing is this: we have this ability to sort of combine these this text together using a plus sign to sort of glue them together, or something that we call concatenation. And so that's something that we will see very shortly, upcoming in a couple of slides. So if you read this code on the screen and it's a little bit scary, or you're not quite sure what it means, that's perfectly normal. With time, with a couple slides, we'll be able to go over all that information, and it won't be so scary after that. Right? Okay. So in order to understand that code that we wrote a little bit on a deeper level, we need to learn about a topic in programming called variables. So what are variables? So variables are essentially this little storage container, or you can think about a box, or this place where we can hold some data, we can hold some information. So for example, what I can do is I can hold in my variable some text information. So I'm going to copy this first example here. And this one says, kindness act equals helping a friend with work. Okay, so in this line that we're reading right here, we should almost not read it from left to right. Maybe we should actually read it in the way that it gets sent into our program here, which we read the text. And what we do is we sort of, let me get out my little annotation. So we sort of say here we have some text, and we want to send that text into my storage container. Okay, my storage container, I'm going to give it a name so I can know what that storage container is called. And that storage container is called kindness act or kind act here. And so anytime I want to use that information that's in my container, what I'll do is I'll use that name kind act, and I can gain access to that information, or we can change the information that's in it. And there's other stuff that we can do along the way. Okay, so this is the creation, we call this the creation of variable. I'm creating a variable here. When I write the equal sign, or you read this equal sign, this is what we call assignment, or I'm assigning some value to my container, my variable here. Okay, this equal sign is very important. It means send that information into my container. Okay, let me clear my drawing. Cool. So we can use variables with much more than just this text information. We can also use variables to hold, here we go, some numbers. Okay, so for example, I can give myself some value, some variable called kindness points. Here, I'll create a new one here. I'll say kindness points is equal to 100 because I earned 100 kindness points. And so this, do you see how on my code editor it changed a different color? And I didn't put it in these quotation marks, okay? So for our string information, our string data, we put in quotes. For our number information here, we do not put in quotes, we just use some number. And then here's another one that you may not be familiar with if you're new to programming, which is this true or false value, which we call a Boolean, okay? So I'll copy this one here to my code editor. And these are three different, what we call data types, okay? So in our program, we can store lots of different types of data. And these are some of the basic ones that you may be using in your project, or just in your Python programs, or just programs in general that you write. So that first one that I mentioned is text, some text information. Now in coding, we call text information strings, okay? We call these strings. Why is it called string? It's kind of, you can almost visualize this idea of a string being like this, continuation or these characters that are put together side by side, or sort of strung together, right? And so we signify that this information is a string by using these quotation marks, okay? So for example, here you can see I have these quotation marks in my coding editor. It made it turn green because of my coding style that I set up. And that will signify to the Python program that this is some string data here as the data type of this kind act variable. Okay, so my message, it could have some spaces, it could have some special characters. It can be like that. There are some edge case, we call them edge cases, or sort of corner cases that you want to be aware of and think of, which is we can put our special characters here, but take a look at this one here. So let's say, for example, I were to put a let's say helping, I wanted to put a friend in quotation marks. In this case here, it looks a little bit funny, right? And if I run my program here, it's going to give me an error. And like I mentioned at the very beginning, Python or programming in general, it's very, very literal, right? What you write, it thinks that's exactly what you mean. So in some edge cases like this, you might have to change that. So for example, one way in which we can change it is we can use something called an escape character to escape these values and tell Python, hey, don't read that as the end of my string. I want you to instead read that as the literal character that it is. As well, we have other tools, like for example, we have different types of quotes in Python. We can use these single quotes, and then it will be able to interpret these. I'll show you here. We can use print with kind act like this in order to see. Do you see how I could see those quotes in my string? So there's other ways that you can get around it. We could spend a lot of time talking about a lot of these edge cases, so that will be something that I'll leave up to you to explore. But just be aware that there's more than one way in Python that you can define a string. Yes, Jaden, do you have a question?
How long is class?
How long is class today? Class today will end at 7 p.m. Pacific time. Okay, so we have
7
about
p.m.?
an hour and 15, a little more than an hour and 15 minutes of
No, so and my time is literally 9.
Yes, depending on where in the world you are, you'll be in a different time zone. If that's too late for you in your schedule, just be aware that the session is being recorded. And so if you need to watch the session at a time that's more convenient for you, feel free to do that.
Another
Okay.
question.
You have another question? Yeah, go for it.
What's so hard that is literally takes 2 hours just to do it?
Why does it take 2 hours to do the class? Because there is a lot that we can learn about coding. And even after the 2 hours of our class today, and even after the 2 hours of our class tomorrow, we still won't be masters of coding, right? This is something that you can spend a lifetime on, and still there's always new stuff to learn, so this just making sure we're all on the same page. This session is completely optional. If you have all the tools that you need in order to create your project, you're welcome to skip the session. However, if you would like to stay and learn more, then that's what this session is for. Okay. Okay. All right. Continuing on. So beyond the text data that we have. Okay. One more question. Go ahead, Aaron. Yes. Do you have a question?
So why do we need only one quotation for the helping a friend with homework?
Oh, okay. Because there are multiple ways in which we can tell Python that this is some string data. And one of the ways that we can tell Python is with these double quotes, right? This looks a little bit more familiar if you've read a book or some something. You'll recognize this as these quotation marks means someone saying something, right? And so this is a little bit more familiar. But also in Python, we can tell Python that this is some string data, or this is some text, a string, by using these single quotes as well. So you may see this when you're reading some Python code, or maybe you even find this easier and want to use this when you're writing your Python code. As well, I'll even go one step further. We have some triple quotes that we can use in Python. I'll let you guys read about that, or we can talk about that when we have some time. But they have different use cases. We could talk about this for a long time, but I just want to sort of keep it on the simple cases.
Okay.
I guess the case that I mentioned was, let's say, for example, I had in my string helping a friend's grammatically incorrect, right? With some homework, right? How could I potentially tell Python, hey, ignore this as the end of my string? We have a couple ways in which we can do that. So one way we can do that is with this backslash character to say, hey, ignore this one that's coming right after it. Don't treat it as the end of the line. Treat it as the literal character that it is. Or if we use this double quote in order to tell our program that this is how we're creating our string, then it won't read this character as the end of the line, the string. It will just read this as the character that it is. So yeah, that's the reason. Okay, so what else can we do? Well, I guess like we saw on the screen, we have some numbers. In this case, this number that we created with our variable, the kindness points, This is a special type of number. This is called an integer. If we're familiar from our math class, these are our whole numbers, right? Not our decimal numbers. These are our whole numbers. For example, 100 or 5 or 12 or -7 or things like that. These are our numbers, and this specific type of number is called a integer. Okay. The next type of data that we can store in our variables is called floats. Okay. Floats is a shorthand way of saying floating point numbers. These are our decimal numbers. So our decimal numbers are just our fractional numbers, right? And so these are things like 4.8, 2.5, -10.6, 22/7, right? Our fractional numbers. And they are written with a decimal point, just very similar to, or exactly the way in which we would do in our math class. And then the other example, which we saw from line 3 over here, are these true or false values, which we call Booleans. If you're interested about why is it called Booleans, you could look that up about this guy, John Boole, so you can read about him and his influence on computer science. But yeah, these are essentially just either true or false. It can either be true or false. The way in which we write that is with an uppercase T or with an uppercase, not true, false, like this, okay? In other programming languages, or maybe you make a mistake, you write it like this. Just be careful. It doesn't understand what this is unless you put it with the uppercase. Look how on my code editor, change a different color so you can see. Yeah, you can see that that's the Boolean value or the true or false. I think for people who are new to programming, this one, before we see some examples, it might be unclear why we need this or how this would be helpful. So if that's what you're thinking, if you're saying to me, Teacher Brendan, I don't see why we would need something like that, just be patient. This is something that's super, super helpful, and we can definitely use a lot, or we definitely use a lot in our programs. Not just in Python, but all types of programs that we write. Okay, so those are some of the different data types that we can use for our variables to hold some data. All right, so we know how to write some information to the screen. We know how to collect in some information. We know how to store that information in some variables. And now let's do some interesting stuff. So for example, one thing that computers are really good at is doing math. So for example, we can use our integers or our floating point numbers in order to do some math. So for example, if I want to do some calculations, I can use the arithmetic operators that we know from our math class, okay? So we have to be a little bit careful, right? So this +1, hopefully this looks similar to what we would have in math class, okay? So I can print out that value here so we can see what it looks like. Total deeds, okay, and I run my program, and it did exactly as we expected from our math class, right? It took 5, we used the plus button to add 3 to it. Now it plugged in that answer into my variable called total deeds, and then I just printed out the content from that variable. I said, hey, show me what that looks like, and that's how I got this answer here. So that one looks familiar, and this one does as well, right? So this one, when you see the minus sign, it's exactly as we see it in our math class, right? So hopefully this one is not too scary for us to see. 20 minus 12, we just do the math problem. It plugs that in here, and it stores it in that variable called cookies left. Now, these two are maybe a little bit different from how you envision from your math class, depending sort of where you are in your math journey. So in our math journey, maybe you're used to seeing the multiplication symbol being like an X, and you might think that if we wanted to multiply like 3 times 5, you might do this. But just be careful, this is not the symbol that we use for multiplication in programming. We use the star. Okay, so maybe that's something that you're used to seeing from your math class, or maybe it's something that's new to you. And so this is how we can do some multiplication. And then finally, as well, we can use this this forward slash symbol in order to do some division. So for example, here, if I take 16 and I divide by 4, right? This is division here. So maybe you're used to the division side with the bar and then the dots over it. But this as well, diffraction is same idea, right? We're dividing 16, we're dividing it by 4. Okay, so with these tools, we can do all sorts of mathematics. So if you're thinking about, how could we do this in our program? I guess the variables show you some examples, right? Let's say I have some program that wants to, say how many products do you want to buy? How many cookies do you want to buy? And then based on the price of the cookie, I need to tell the customer what they need to pay, right? So that would be an example of how I could use some multiplication in my program. And lots of other examples as well that might be super useful. Okay, so if we put it all together, your programs might look something like this, where you have some variables that hold different values, some integer values or floats or things like that. And then from there, we can do some math. We can do some addition, some multiplication, division, things like that. And then you can store the results in some variables, which you print out or do other calculations with along the way, like this. Okay. Just be aware, rules of PEMDAS apply. So when you're thinking back to your math class, right, we'll take, oftentimes in coding, we take a sidestep and sort of think about the things that we've learned in our math class. This is one of those times. So you just want to make sure that you remember your rules of, if I have some expression, when do I multiply? When do I add? When do I divide? Follow the rules of PEMDAS and they will be applied here, right? So we do our little calculation, the result gets plugged into my variable, and then I go and print out the answer. Yes, Changin, do you have a question?
So I think is like X symbol for exponentiation 2 times signs?
Very good. Yes. So you might be like Changin mentioned, there are other mathematical symbols that are not right here on this slide. So for example, if I wanted to do exponentiation, how could I do something like that? That's not on this slide here, but as was mentioned, we can do like 2 to the power of 5 or something like that. And the way in which we show it is with this double star here. So we can see that's just 2 times 2 times 2 times 2, 5 times, right? And so we use the double star in order to show that. You may have thought maybe we use like the up caret or something like that in order to represent that, but just be careful. That's something else in computing. So just be aware that in Python, to do exponentiation, we would use these this double star in order to represent that. Or even maybe as well, now that we're talking about exponentiation, maybe you want to do some square root or something like that. We have tools in order to do that. So if you're curious, there's a math library in Python that has a lot more tools. And we'll talk very shortly about what a library is and how we can use it. We're actually going to use one very shortly. And so there's a square root function that you can use to get the square root of a number. Yeah, you can do that. Or if you're really a clever mathematician, we can sort of take this like this, and potentially what we can do is we can sort of raise it to the half power, right? Sort of going in the backwards direction. So depending on your level of comfortability and in your math expertise, right? Different ways in which you can solve problems. So feel free to go and explore. You can ask Delvin, or we can talk about this towards the end of the class about if there's some mathematical things that you're interested in doing that just weren't on the slides that you would like to talk about, that we're more than welcome to do that kind of stuff. Okay. Mingxi, do you have a question?
Yeah, so like the opposite of the power function, it's the square root. So I would like to know what that is then.
This one?
The square root.
So I guess I showed you one way in which you can do that. So for example, in mathematics, we can raise something to the half power, and that's technically taking the square root. So that's one way in which you can do it. Also, there's, like I said, there's a math library, and then we can do math dot square root like this. So if you're interested in using the square root one, definitely look it up. It looks like this, right? And then you can do that. I guess I'm purposely shying away from showing you this example here because very shortly I'm going to teach you about what a library is and how we can use libraries in our code in order to do some functions that we didn't specifically write ourselves. So
Do we have to use the math library to do the square root function? Or
definitely not. So for example, here's a way in which you can calculate a square root. So look how I'm using my math background, my math expertise to know that if I have a number and I raise it to the half power, that's actually the same thing as taking the square root. So if I have 64, what's the square root of 64? Well, that's 8, and that's the same thing as raising it to the half power like this.
okay.
Yeah, so I'll show you again. Look, how about this one? This one, square root of 16, that's 4, right? So this is I guess the further you go in your math journey, the more that you can learn about some cool little shortcuts or tricks or stuff that you can do. That's one of the cool things about sort of really going far with math is learning that fun stuff. Yes, Changin, do you have another question?
If square root is to the 0.5, which is a half, then is cube root the number to a third, to the power of a third, and fourth root is the power to a fourth, and so on. Is that how it works?
That is a really great observation. And I think what I'm going to do is I'm going to ask you, I really want you to explore. So, what I would recommend to you to do is, take a number that you want to take the cube root of, right? And then try and do that, right? See if you can apply it in that way. See if you can get it to work. Maybe it's not quite exactly going to work in the way that you thought. Maybe it works exactly. So I think for the sake of making sure that we keep going along and cover some of the other topics, I'll leave this as a challenge to you, which is if you're interested about calculating cube roots and even further that, fourth or fifth or things like that, try and play around with it, right? Take a number that you know the answer to, and then see if you can try and calculate it and get to the answer. And then either it matches or it doesn't. One thing that you're going to learn along the way is that when we're working with these fractional numbers in computing, it often raises these new challenges that we didn't really expect when we're sort of new to that. So how do we represent this idea of, let's say, for example, one third, okay? Right, one third. What is 1/3? Well, it's 0.3 repeating, right? But how do we replicate that in our code? Technically, it's impossible to create this idea of infinity in our program because we have a finite amount of space in our computers to store information, right? So that's one of the tricky things that goes along with doing math and computing is that computers, they're not good with this idea of infinity and holding, for example, a value like 1/3. This is close, right? This is depending on the situation. This is very, very close. Is this truly, truly accurate? No, this is not the right answer. Okay. All right. Let's keep going on. So what are some other information or some interesting things that we can do with our Python code? Well, oftentimes when we have these variables, we want to organize our data or store it in a way that makes sense to us. So probably a lot of us have had some experience with maybe reading or interacting with some sort of spreadsheet, right? And maybe you have a column, and the column represents the student's name. And then the next column represents their grade that they're in, right? And these are natural groupings of data that belong together. And so as well in our Python program, we want to be able to collect some information and sort of group it together to organize it in a way which we know that these items they share something in common, right? They have either this common name or age or things like that categorizes them. And so we can do the same with our Python code, and we're going to do so with something called a list. Okay, so what is a list? Essentially, it's just a way of us to be able to store multiple of these variables together in a collection where they are working together. So if I look at this example here, so this one says I have this variable called kind x, and what's in common with these? Well, these are a bunch of strings that represent some kind acts that I could do. For example, helping with homework. So maybe I help a student with homework, or maybe I share my lunch with someone, or I give someone a compliment, right? These are some examples of kind acts. And so because of that, they have this natural grouping, and I would like to store them together. And so what I do is I use these. Do you see how I use the square brackets around it, around my variables? And then what I'll do is I'll separate my items in my list with a comma. Okay, so this will create for me this this list of these kindness acts. I'm going to show you what happens when I print that out. So when I print out kind acts like this, it's going to show me how the representation of how my list looks like. Okay, so you can see these different strings that are together, and it shows the individual pieces. Okay, so this is, for example, a list of kindness acts, and this is just a list of strings. But as well, you could have lists of other things, like a list of names. You can have a list of points. You can have a list of Boolean values, right? True or false values. As well in Python, which we don't always get in some other programming languages, we have the ability to mix and match. So there's pros and cons to be able to do stuff like this. But for example, I can mix and match, and I could have an integer value along with some strings, right? So I could do something like this. I could change this one. This could be a Boolean value, right? This is okay. This is something that we're allowed to do in Python. Okay. Now, how can we update our list, either by adding new items to our list or removing items from our list? Well, we'll start with a list. So for example, if I start with this list, my list is called good deeds. So these are some good deeds that we've done here. So for example, I cleaned up the trash and helped carry some books. Well, what I can do is I can use this append function here. Okay, so I'm going to copy this line. And what I'll do is I'll start first by saying the name of my list that I want to modify. And then after that, I'll use this dot, okay, the period after that. And what I'll say after the dot is what I want to do to that list here. And so in this case, I want to append, or this is something that will help us to add on to my list. Okay, so now that I've added on to my good deeds list, okay, I listened to my friend, great. Let's see if we can print it out like this and take a look at what it looks like. And we'll notice that my list now has this new item. And interesting enough, look where it popped up. It popped up at the very end of my list here. So here are my first items. Look, cleaned up, trashed, helped carry books, and then lastly, it added on this this new item to my list, the one that I just added. Okay, that's how we can add a new item to our list. But additionally, what we could do is we could remove items from our list. So I will use this remove method here, this function. And what I'm going to do is I'm going to removed cleaned up trash. Okay, so that was my very first item in my list. Helped carry books, listen to a friend. Okay, and if we think about it, right? Cleaned up trash was my first item, but that got removed here by line 3. Okay, and then on line 2, that added to my list here, my good deeds list. And so that's why we end up with a list of helped carry books and listen to a friend. Okay, and that's the way in which my my list looks like. And then beyond that, there's a lot more that we can do with lists. I want to, more than we have time to talk about in our class today. So I just want to kind of give you some ideas. The first things first, when we have a list of these items and you say, well, how can I just get one of them at a time? I just want maybe the first one or a very specific item in my list. Okay, so for example, if I want to know, hey, what's the first item in my list? Let's remove these lines here so we can just see. What we can do is we can use our good, so we'll call our variable by its name or our list by its name. And in this case, if I want to access one of the items from my list, I can use this bracket notation here, okay? So this kind of almost looks like a mini list. And what I'll do is I'll put in a number here, okay? For example, I'll put in 1. And I'll show you what happens when I run my code. It prints out helped carry books. Now, the reason why it prints out helped carry books is because these lists have, well, they have an order to them, right? And when we're doing some counting with computing, the way that it typically works is we do our counting starting at 0. Okay? So if we're thinking about I'm doing something here, it's called a comment, where I write some notes in my code that doesn't actually get read. But if I'm looking at the sort of position of where each of these strings are, well, this first one is at position 0, and this second one is at position 1. So for example, if I want to get access to that very first value, I can put 0, and that will print out cleaned up trash. Okay, that will give me that very first item. Okay, there are different I guess we can add on to our list. There are different tricks as well. So you might say, well, what if I have a list and I want to get the very last item in the list? I want to grab that last good deed here. There's some different tricks. One way in Python, which we can get access to that last item, is by, you're almost thinking about wrapping around to the other side, right? If this is the 0th position, we can wrap around, go -1, go to the other side, to the left instead of to the right, and get access to that value there. And then I have that one if I'm interested about getting the last one. There are other tools that we can use in order to get different ones. That's just one simple way in which we can do that. Okay, so that was a very, very short and brief introduction to lists and the types of things that we can put into lists and access items and things like that. There are, there's a lot more that you could potentially want to do with sort of creating lists. And as we get closer to the end of the day, and then also definitely tomorrow, I'll give some of my suggestions of ways in which it could be helpful in your project. And depending on how you want to use your lists, you might want to do different things with it. So for example, one of the things that you might want to do with your list is maybe you want to print out each of these items in your list, right? That's something that we'll learn to do when we learn this topic called a loop. Okay, so that's something that we'll revisit with time, which we won't learn just yet. Or there's other things like, maybe for example, you want to add an item to a very specific position in your list. Or maybe you want to chop off your list and turn it into 2 different lists, right? There's different ways in which you can do that. I won't show you everything, right? I want to make sure that it's all stays in sort of small bite-sized chunks that we can sort of learn piece by piece. And then as we sort of practice with these lists, play around with them and sort of see, oh, hey, this is something that I don't quite know how I could do. Is that something that we can do, right? Teacher Brendan, how about if I wanted to add an item to this middle position in the list? Is that something that we can do? Those are things that we will sort of gently explore with time, not just all at once. If I just dump all the information about everything you can do with a list, you'll probably just remember like one or two things and then forget everything. And so really the best way of learning with coding is just actually writing code. And the things that are helpful to us and that we use, we will naturally learn and practice and remember. And the things that we don't use and are not super useful to us, then that's okay. Those are things that we can always look up, because as programmers, this is something that we will do all the time, which is we will look things up, we will read documentation, we will ask questions to our teachers, to our classmates, and other things like that, in order to sort of remember how these things work, because it's not possible to memorize absolutely everything. So just make sure that you keep that in mind, going forward for the future. Okay. All right. So that's a little bit about some of the basics of what we can do with Python. And now that we have this sort of basic introduction into sort of some of the things that we can do with writing Python code, you'll say, okay, cool. Now what? How do I start using this to build stuff, right? How can I make a game? Teacher Brendan, how can I make a animation or something that's interactive that a user can sort of maybe see this window with these drawings and buttons and things like that and be able to interact with my code? So in order for us to do that, we need one of two things. Either one, we need a lot of experience with writing code in order to write a bunch of code that's going to help me to pop up this window. And we have to write a bunch of code to figure out how we can create these buttons that appear on the screen and all that kind of stuff. Or the other option for us is we can use some code that was written by other people in order to jumpstart our project and sort of get started with drawing and animations and all that kind of stuff a little bit faster, and without having to really learn these very complicated details, which we will learn with time about writing code. And so one of the great things about writing code is that once you write code, you can share it. You can have other people interact with your code and use their code within their code. And that's what we're going to be doing today. So for example, today what we're going to be doing is we're going to be using a library. Okay, specifically, we're going to be using a library called Python Turtle. So first we want to talk about what is a library. Well, in the context of what you know a library to be, a library is a place that you go and you check out a book. Maybe that's where you go and study and do your homework or things like that. But essentially the idea of a library is you go, you find some books or some magazines or CDs or things that are interesting to you. And then you go and check them out and they'll say, okay, this is the date that you need to bring them back by. And when you're done, you can come back to the library and return your books. And so essentially, we're going to do something that's very similar in this context, which is there are some other programmers who have written some code. Now, these programmers in our context have written some code in order to help us, do some drawing on the screen, to create this window, and to do some other stuff like that, okay? And the developers or the coders of this library, they named their library or they named their book Python Turtle, okay? And we'll see why they call it Turtle very shortly when we get started. And essentially, like I mentioned, it's going to have all these functions that we can use with it. We can say stuff like, hey, draw this line, right? Write this text. Move the pen left, move the pen right, go forward, all that kind of stuff, without having to write all this complicated code in order to get started. So that will be one of the benefits of what we are doing today. Okay. So the idea of what Python Turtle is it's this graphics library, and it's gonna pop up this window on the screen. And that screen is going to be this little interactive window in which we can sort of write some code that automatically goes and does some drawing on our screen. And as well, we'll be able to do some interaction with the graphics window that we have as well. So it's going to create that. Like I said, at this moment, what do we have? Really, we just have my code editor where I'm writing my code. And I have this little shell at this bottom, this window, where I can show some text to the user. Even as well, we can collect some information from the user. But currently, I don't really have a way that I can do some drawing, right? So for example, if you said to me, hey, Teacher Brendan, I want you to create a button. Well, how could I create a button, right? I don't really have a good way at this moment, just with my print function, to do something like that, right? How do I do that? Here's my button, right? We might think, okay, here's my button, right? But even then, is this interactive? No, right? I can't click on my button. You can have the user enter some information. Hey, click yes or no, and then you can do some stuff with that. But we're definitely missing out on a lot of functionality that would be really fun to be able to use and integrate into our project. So that's what we're going to use Python Turtle for. So we've already written our very first Python program, and now we're going to write our very first Python Turtle program. Okay, so what we're going to do is we're going to take our little Python turtle and we're going to make him walk around our screen. So what we need to do in order to gain access to this library is to use this special word. Special words in programming are called keywords, and it's this import keyword. Okay, so when I write import, it's telling Python, hey, Python, go and fetch the code for this library so that I can use it within my own program. And so when I write something like this, okay, I'm going to say, hey, go to that library. Let me just copy it over really quickly so you can see it within the editor. I'm saying, all right, Python, go to the library that I've collected, that you brought the code in for me, and I want you to specifically create a turtle, okay? So when we see this dot, it says, hey, use this function, and specifically this is a function that belongs to that library, and this function is one that helps us to create a turtle. And then here what I'm doing is when it gives me that turtle, I want to collect it, or I want to save it. I want to be able to be able to refer to my turtle by its name, or however I want to call it, so that when I tell my turtle to change the color that it's drawing with, or I tell it to go forward in a certain direction, it knows exactly what to apply that to. Okay. Yes, Jaden, do you have a question?
Void itself is not my turtle equals to turtle dot turtle is not. It's import t at import turtle as t. So then you can there's like t dot color, t dot board, how much, t dot right, t dot left, t dot color, t dot pen color, t dot fill color. And in order to be saved, just do t dot done with the parentheses, so we'll save it.
Yeah, thank you for making that observation. I'm sorry, can I ask you, was your question why did I not write import turtle as T like this?
Yeah, that's the main. And why do you write my last turtle equals to turtle dot turtle parentheses?
Okay, here, let me explain. We could do this. Okay, so you are absolutely right. Okay, and then I could use T along with the commands. So we'll learn some commands, and actually, so we'll jump to this line here. So I can use the shape command in order to change the shape of my turtle. Okay, I'll show you what that looks like here, like this. Okay, so I'll run my code. What's happening? Well, I get this little graphics window. Do you see? I didn't write the code for this window to pop up, right? This is coming from the
When you
library
type in
code.
turtle, it works.
Sorry, Danny. I have to make sure you follow the classroom. So, if you would like to follow up, just make sure that you raise your hand. Okay. So I'm going to finish my point that I'm saying, which is the graphics window pops up, and look, I have this little turtle in the middle, right? This is my turtle that's going to be able to do my drawing for this. So I could write it in this way. If you're curious about why I've written this first line of code like this, like my turtle here equals turtle dot turtle here. The reason why I've showed you this is that oftentimes in programming, there's ways in which we can write something that is doing the same thing or doing something that's very similar in a different way. And when I write this line here on line 3 like this, I'm really showing you the pieces of how this turtle gets created, right? And so I'm saying, hey, go to the turtle library and grab this turtle function. And this turtle function, what it's going to do is it's going to create this turtle object for me. And then I can save it in a variable. So I think that, if you already know about Python turtle and you already are familiar with, writing import turtle as T and doing things in that way, then please be welcome. Please feel free to continue writing your code in that way. However, for my beginning students who need to see this visualization, I think that this is really helpful for us so that we can understand the individual parts to see how it's working. And then also down the line, it's really helpful to say, well, I guess this is something that we'll talk about tomorrow, which is in Python Turtle, we can have more than one turtle. And so I can do something like, hey, my second, if I can spell it right, my second turtle here equals turtle.turtle. Hey, turtle, make me another one, right? Here's my other one. This is the one that I want to use, right? I want to move this one, or I want to move that one. That's something that we'll be able to see tomorrow. I guess I'm giving a little jump start on that one, but that's another nice way of seeing very explicitly, very specific what is happening behind the scenes. So hopefully I was able to answer your questions with that one. Okay, so continuing on. So when I use this turtle function to make my turtle here, I run my code. What did we see? I'm gonna make this a little smaller. See it a little bit better. What do we get? We get this cool graphics window. Look at this. This is awesome, right? This is a great place where I'm going to be able to do some drawing, have some interaction with the screen and other stuff like that, right? Look, it has these little buttons that I can close out of it too. And do you see by default? So by default, what happens is that the graphics window or the turtle library, it will give you this little turtle that's shaped like an arrow, okay? That's just the default behavior. And as we saw in the slide, if we want to change the shape, we definitely can. And there's other shapes that we can use. I'll show you in a second how we can do that. But let's figure out how we can move this turtle around. So I can do stuff like my turtle. So I'll say my turtle's name here, and then I'll do this forward command. Okay, here like this. All right, and I run my code. Do you guys see that? It happened pretty quickly. Maybe I'll make my window a little bit smaller so we can see. It's gonna pop up really quick here. So I can run my code, and did you see it? It jumped across the screen just like that. My turtle moved from the center out to the right side, right? So at this point, probably we have a couple questions. We're saying, well, 100, what's 100, right? How do I know what 100 is? How do I know what distance that really represents in terms of drawing on my screen? And then the other thing you might be thinking about, maybe this is more obvious to some people than others, which is, do you see how the turtle went to the right side first? Well, I said forward, how come it went to the right side? So maybe that first one is a little bit more obvious to see, which is, Okay, if by default my turtle is facing towards the right side, then I guess it makes sense. Let me get out my little annotation, right? If my turtle started out in the middle and it's facing this way, right? Here's my turtle. I said go forward. Well, that kind of makes sense, right? This is going in the forwards direction, okay? And I guess when we write that next command there and we tell our turtle go backwards, that it should end up going in this direction, okay? So let's give that a try. Let's see if we can do that one. So instead of going forward like this, all right, backward. This, I'll run my code. And there you can see, just with this command here, I got my turtle to move in the backwards direction. Okay, so those are two pretty useful commands when we're using this Python turtle library, the forward and backwards. Okay, and then now turning over to that other piece, which is saying, hey, what is 100, right? What does 100 mean in this context? Well, always when we're sort of thinking about movement or distance or things like that, we'll have some sort of unit of measurement. And we do have unit of measurement in this. I'll get to you a second. It looks like Niema. Sorry. How do I say your name? Help me out here.
Neve.
Neve. The H is okay, kind of like a V then.
Yeah.
Okay, interesting. Go
So,
ahead.
like when I typed in my turtle forward 100, it didn't work. Like it was the exact thing. So I don't know. It's not working.
Okay, that's a great question, and definitely a place where a lot of students could get stuck at. So there could be a number of things. Maybe, for example, you see an error message at the bottom. Another thing is depending on your setup, maybe the window flashed up on the screen and then closed. You can you know, you can do something like this. In some contexts, that will actually hold the graphics window from closing so that it stays open until you explicitly click the X button to close it. I guess my answer is it depends on your situation whether you're seeing an error in the console. So maybe I did something. I've done this all the time, right? So here, this would give me an error. My graphics window popped up because it created my turtle, but it's trying to say to me, hey, oops.
Because mine said it said that it's missing one required positional argument distance. So
Oh, okay. So let me see if I can replicate that here. Oh, let me fix that. So here, go backwards like this. Aha! I think your error might look something similar to this, right?
mm-hmm.
Okay, in this case, what it's trying to tell you is the authors of this library, this Python turtle library, they're trying to tell you, hey, whenever you use this forward or backward command, I need you, in order for my code to work, I need you to tell me how far you want to go. So in order to fix that, what I'll do is I'll put when we learn about functions, what we're going to learn is that we can send some information to our function. In this case, we're going to use some integer value that's going to represent how far I want to go. So in that first example, I went 100, or for example, maybe I double it and I put 200. And then if I run my code, then hopefully that one should go away. I shouldn't see that error anymore, like this. And then I should see that it went, you know, double the distance as what I was seeing from before. Okay.
I already put in 100.
Okay. In that case, maybe I was not accurately seeing where the problem was. Are you able to like take your code and copy and paste it to Dylan so he could see? It might be a little bit easier if you know, he could see your code.
Okay.
I
How
guess
do I
I'm gonna try.
try him?
Okay, so what you do is you can copy your code and then you go to the chat window in Zoom, and then you go to maybe my view looks different because I'm the host. I can go to actually, maybe, do you guys see the participants window in Zoom? Or is that just me as the host?
Brendan, I think everyone in the Zoom can also direct using the direct message and send the chat to Dylan.
Okay, perfect. Neve, are you able to see where he is in Zoom?
Yeah, I can just type. I can type.
Okay, perfect. Yeah, sorry about that. Sometimes it's a little challenging to debug the code without seeing it. All right, so we can move forward. Oh, sorry, Oscar. Yeah, you had a question.
I need to go to the bathroom.
Okay, yeah, that's fine. Yeah, go ahead. All right, so continuing on. So from now, what we can do is we can move our turtle forwards and backwards, and we can essentially draw some lines. Okay, so beyond that, you know, make sure that you give this a try. Right, try and walk your turtle around the screen, move it forward 100, 200, 50. You know, I think even a good thing to sort of think about this distance is to try and think about like what is 1 or 2 or things like that here, like this, to sort of see, oh, like I could barely see the line at all, right? 1, what does that really represent in terms of this distance here, right? That's something for us to think about. Yes, Jaden, do you have a question?
But the turtle beat disappear off the screen.
I'm
If
sorry,
you like,
first part,
if
can
you
you
do
repeat?
like backward 1,000,000, it say goodbye. You can't even see the turtle.
All right, let's give it a try. I like that idea. Let's do it. Here we
And
go.
not even,
Oh, there goes my
not
turtle.
even if you make it big, you can't even see it. You can't move it. You can't. I don't think you can move the screen.
Yeah,
Of my turtle.
unfortunately, that's the case, right? So one thing that we'll want to be aware of is, sort of, well, actually tomorrow we'll learn how to sort of set up the screen so we can think about some
What is
boundaries. And one thing that will be cool about when we learn how to do that is that when we have this window, oftentimes, I don't know if you guys can sort of think in your head of some examples in the real world, but oftentimes in the real world where you have some text that like overlaps onto the side of the screen, what will happen is they'll have some sort of scroll bar where you can sort of click with your mouse and scroll to the side in order to see the rest of the picture, right? And so that's something that we'll learn to do tomorrow is if we set up the screen to a fixed size, then we can use the scroll bar in order to make sure that we can scroll in order to see everything. Or as well, when you create your screen of a fixed size, then we can sort of think about the boundaries of the window that we're working in, and that will help us as well in our project to make sure that when we write that code, we're not going outside the boundaries. So you can still, like, for example, if you have a game, right, you want the person to be able to see the character, or do that kind of stuff. So that will be important, which I promise we will get to tomorrow. And do you have another question? Jaden, did you have another question or just forget to?
Yeah, last time you did it, why does it say a string in line 500, 102?
Why is there a string in 500? I'm sorry, I didn't quite
So
understand
it
the question.
says that when you like delete it like that, the first time that you did that, it says string problem. It like no
Okay.
string problem. It said that it's like 512. I don't know why I said that.
When I closed out the window, you're saying?
Like close like the turtle with the first time.
Like this?
What the flip just happened? Like look at the numbers. What you don't have that much.
That's exactly right here. Let me close out this little assistant thing. So what's going on here? Definitely, it is very valuable to read these messages at the bottom in order to understand what's going on in your code. One thing that I want to point out is that when we're sort of just at the very beginning parts of learning to write code, a lot of times these errors might be confusing or difficult to read or figure out what's going on. And so definitely be patient with yourself. What's going on here? What's going on here? Okay, so it's saying, hey, in this file that you have on line 4 here, so it's complaining about this one here. It's saying, okay, from this library frameworks, Python framework version 3.12, this Python version that I have, Python turtle, okay, at this line, right? So it's jumping into some portion of the code that I didn't write. This is the code that they wrote here. And then they have this reference to it, and they're saying some information about it. They're saying here, invalid command named dot canvas, right? So because I didn't write the code within that library, the Python turtle library, especially if I'm a beginner, it's hard for me to go and figure out what it's trying to tell me in this case. In this situation, this is fair to ignore an error like this. Don't worry too much about any potential errors that are coming from the library unless it's impacting your project. Especially because we're working on limited time frame. What you really want to do is build out something that you understand as much as you can as possible and really get this working example that you can showcase what it does. And little things like this, these are things that we can research along the way and figure out what's going on. But for today, it's just our very first day of learning Python. We're not going to go into the error, any sort of messages or errors or things that are coming from the library, unless we've sort of broken our code and need to configure it in that way. Okay. All right. So what else can we do besides drawing our line moving our turtle? So we can also make our turtle turn. How do we do something like that? Well, we can use these left and right commands. Okay, so for example, if I use my turtle's name here, like this, and I use my turtle dot left 90, then let's see what happens. So here when I run my code, I can see that my turtle faces and is pointing in the upwards direction. Okay, the upwards direction. Let's go back to the code here. Why did it do that, right? My turtle dot left 90. Run our code. Let's see one more time. Let's see what's going on here. Left 90. What does 90 mean in this example? Anyone want to tell us while I get out my drawing table? Okay, if not, here we go. I'm gonna take us into. Oh, is it Steven? Did you have a question? Oh, Aaron, you had a question?
Like I was gonna say like that, for like the right and left, like the measurement is degrees.
Very good. Okay, so we'll go back to our math class over here, as we often will. And one thing that I would like you guys to do when you're writing your Python turtle code is I want you to imagine this turtle graphics window as a coordinate plane, right? As a two-dimensional coordinate plane, as we would in our math class. So for example, in our math class, we might write some little hash marks, and this represents, hey, this is 1 unit of measurement away, this is 2 units of measurement away, right? 3, so on and so forth, like this, going so on and so forth, all the way out, right? Going, and this is moving in the positive x direction. Here's the negative x direction. Okay. And as well, here we have, right, this is a two-dimensional space that we're working with. Here's my y-axis, right? Here's my y-axis. This is the positive y direction, and this is the negative y direction, right? So we can sort of think about everything being in this coordinate plane, and I want you to think about here, I'm going to draw a little Actually, I really don't have to because it's going to pop up on the slides here in a second. But ta-da, that's my beautiful drawing of a circle. Perfectly rounded, right? So we want to sort of think about the angles of measurement within this, right? And sort of looking at the measurements of our degrees that we're turning. When we're thinking about these angles of measurement, we talk about degrees. So for example, if I wanted to turn 90 degrees, that would face me in the upwards direction. As you can see here, let me change the color. You can see my turtle is facing in that upwards direction because I've turned left, so moving upwards by 90 degrees. Okay, so that's what we can do to move in that direction. Okay, so I suppose using my mathematical knowledge, if I wanted to change my command and did command, hey, my turtle dot left 180, well, that should face me in this direction. So let's do a little experiment here. I clear my drawing, close out my window, and then here, let's see if I can turn all the way. So, oops, left by 180 degrees. I run my code again, and we can see here, look, now I'm facing in the complete opposite direction like this. So my turtle is now facing 180 degrees. So I flipped all the way over to the other side. So that's a way in which we can turn. And then also we can use the right command. Okay, so I'll show you, for example, let's say I want to do a 45-degree turn going to the right. How could I do something like that? Well, I run my code, I take a look, and you see how, I'll get out my drawing one more time. Here's my coordinate plane. Oops. Not perfect, but you guys get the idea, right? So originally my turtle was facing this way. And if we think about what 45 degrees is, we just sort of split our line in half, right, on the diagonal. And then this angle here is 45 degrees, right? So that's why my turtle's facing in that direction, because I did a right turn and it's by 45 degrees. Okay? So that being said, that's the way in which we can turn our turtle. Okay, so like I said, why 90, why 45? Everything is sort of represent of these degrees of these angle of measurement. So, just make sure that you sort of think back to your math class about how we can turn in different directions. Like 180 would take us in the complete opposite direction. Or, I guess a left turn by 270 degrees would be the same thing as a right turn by 90 degrees, right? So we can sort of think about the different ways in which we can move around and turn in that way. And then also you could technically negative angles, right? This is something that's possible as well. We can do a negative 45 degrees, but do a right turn, which actually would send us back in the other direction. This is really confusing if you're reading your code, but it's possible to do. So you can do something like this. And then even I'll show you the, watch this. I'll go backwards, and I'll go backwards by negative 100 distance. What do you guys think this will do? If we're thinking about it as an XY two-dimensional coordinate plane. You guys see how it moves me in the forward direction? So again, possible. Is it a little confusing? Sure. Yeah, it is a little bit confusing, but as long as you sort of understand how the Python turtle graphics window works, then you have lots and lots of tools that you can use in order to navigate around the screen. Okay. So now we have a lot of different tools within Python turtle. Let's see if we can do a little challenge in order to draw a square, right? So if we want to draw a square here, let me do my little animation here. Okay, so here's my square, right? And so one thing that we have to notice about the square is that these sides have the same length. So if this is this has length A, then this also has length A, and same one with this one, and same with this one, right? That's the property of a square. And then similarly as well, right? All these angles that we're measuring will have the same angle, right? These will all be 90-degree angles that we're working with, okay? So what we'll need to do is we'll need to write some code to do some forward commands, and then turn, and then forward, and turn, and forward, and turn. Okay? So I'll give you a second to give that one a try. Can I make the eraser larger? No. Okay. So give that one a try. Okay. Let's let's do it together. So if you're not quite sure how you can get started on this one, let's do it together. So what we would do is I'm going to think about my turtle. My turtle starts in the middle. What I can do is I can maybe just move out to the side, and maybe I'll have that be the top edge of my box, right? So if I sort of do this and then sort of visualize what I want this to be, what I can do is here, I can draw shapes like this, right? Cool. This can be the top edge of my box. So if that's the case, then the next step that I want to do is I'll want to do a turn. Specifically, I'll want to turn to the right, and I'll want to turn to the right by 90 degrees. Okay, so let's do that. So like this, I'll turn right, and I'll turn by 90 degrees. I run my program again. And now my turtle is facing in the downwards direction, and it's ready to draw that next line. Okay? So, like I said, all the sides of the square have the same size. So what I'll do is same idea. So here I drew my edge, I turned, I drew my edge, and then I suppose I'll just keep on, do a little copy and paste here, right? And I'm kind of just working my way around the square step by step. Okay, I turned. Now I'll do another forward command. Great. All right, I'm almost there, right? Okay, now I need to do another right command. And then I know I got to go forward one more time. And I'll run my code. And ta-da, it will look something like this. So this is what I have at this point. This is my square. Okay. Yes, Jaden, do you have a question?
Why do you just do it one by one? Can't you just not copy? Like, do one of those the copy ones, then redo ones, then when you see it or one step away, just use the one you need? It's easier.
I'm sorry, what do you mean by use the one you need? What do you mean by that?
You see the first line you have this, right? You have
Yeah.
to already just copy the whole thing and repaste it. What? Then see, oh, you're there, then do it again twice. Then after you say, what code do you need? But it is basically T dot turtle forward 100. You just copy that, paste.
Yes, definitely. I didn't that first time because I wanted to
And you can actually use T dot hide turtle to hide the turtle.
Yeah, so let me show you. Jaden is like one step ahead of us at all times. So he's saying, Teacher Brendan, why didn't you copy and paste? Totally. I can realize that these are all doing the same thing, right? So I just need to make sure that I copy and paste this 4 times. 1, 2, 3, 4. Ta-da. Here, there we go, right? And he's also mentioning another command, my turtle here, turtle dot hide. Okay, so if I use this command, it's a pretty cool one, to hide hide my turtle. Okay, so it's I'll check this, but something like this, right, Jaden? To hide
Is
the
T dot
right.
hide turtle. T dot hide turtle, I think.
So turtle dot hide, something like this.
T dot like my turtle dot. I'm pretty sure like my turtle dot hide turtle.
Oh, that's right. Like this, you're saying.
I don't think there is any holes, like any underscores. I don't think there are any underscores. It's not like
There we go. So that's how you can hide the turtle, right? You can do that up front if you really want to, if you don't want to see that turtle screen, right? Okay, but these are the things that if you don't use it all the time, right, you forget it. You can just ask someone or look it up. Yeah, there's hundreds of commands, so not easy to memorize them all unless you're actually using them all, which is not very often. Okay, but yeah, definitely if you don't want to see the turtle drawing the screen, you could use something like this. But the observation that we want to make is look at all that copy and paste, right? Look at all that repetitive code. Can we simplify that, right? So let's say, for example, in my Python turtle program, I said to you, hey, what I want you to do is I want you to draw an octagon, or I want you to draw like a 50-sided polygon or something like that. How would you do that, right? That would be a lot of copy and paste. And so we have a tool in which we can use to make our life a little bit easier. And that tool is called a loop. So the idea is that we're going to have some lines of code that we want to execute. And what we're going to do is we're going to isolate those lines that are repetitive, that we want to repeat over and over again. In this case, those lines of code are this forward command and this right command, okay? And specifically, we need to do that 4 times, okay? So we'll need to do this 4 times in order to draw our box. And so we want to have a way in which we can tell Python, hey, Python, do these specific lines 4 times. And so what we'll do is we'll use this idea. It's called a for loop. So I'll tell my Python code, hey, these lines here, sure it's indented properly. Python really cares about indentation. I'll tell you why in a second. So I'll write for I in range, and then the number of times I want to do my loop. And then I'll write the 2 dots. 2 dots is called the colon. And after that, I jump to the next part. Okay, the next part is the block of code that's going to be executed as a result of my loop. Okay, so how we show Python that this code is part of the loop is that we indent it. Okay, so I just on my keyboard I hit the tab to shift it in to show that it's underneath this loop and it belongs to the content of this loop here. Okay, so this will help me to do that same thing, and with just a couple, right, those 2 lines of code and then another line of code to tell it to repeat that many times, I'm able to do the same thing, right? So if I want to go back to my example of, well, let's say, for example, we want to draw like a 17-sided polygon, right? How would we do that? Well, either we can do all this copy and paste, or we can just change our code, right? So 17-sided polygon, let's make it a little bit smaller so it's easier to see. By the way, for a 17-sided polygon, what would be my angle in which I want to turn? Any mathematicians? Well, I could.
I think it might not 360. That's just a circle. This be repeated. Not 360.
So maybe I could do a little math in order to help myself out, right? Yeah, Changin, do you want to help us out?
I think it's supposed to be 180 minus 360 over 17. Correct me if I'm wrong. I might be wrong.
Yeah, so there's a couple ways in which we can get there. Let's give this one a try here. So there we go. I can sort of take take my full turn, right, my 360 degrees, I can divide it by the number of sides that I have, and that will be the angle in which I need in order to create my 17-side polygon. So, you know, something that would have been really complicated to do without the loop becomes a lot simpler when we actually learn how to use it. Okay. Okay. So, oh, what's going on with my? Okay, that's okay. I can fix that. Okay, maybe not. That's okay. Hopefully we can still read this slide as best as possible. But now that we can do some cool things like, you know, going forward, turning, drawing some shapes with loops and stuff like that, let's add some color and some excitement to our example. So if I want to, I can add this pen color. Okay, so here's my turtle, and I'll use my turtle, whatever your turtle's name is here, and I'll use pen color. And I can pick a color, and then let's show what it looks like. So I'll do my turtle dot forward, say 100 or something like that. I run my code, and look, I got a red line that appears going out to the side. So what are the colors that we can use? There are lots of these named colors. I assume if you stick to the sort of the color, the main colors that we know, like red, green, yellow, blue, purple, orange, stuff like that, that color should exist and be able to be recognized by the turtle library. As well, there's a website I can share with you that you can see what some of those named colors are. As well, we have this like hex code that is representative of that. So let me show you colors, this one. Okay, so for example, if I'm looking at this color and I say, hey, I really want this color, it's beautiful, I want that one. Here, this is showing me the turtle name that it will understand, right? So if I use lime in my code here, then it will understand it to be that color. And there's my lime line. As well, all these colors, you can also make them up by these hex values here. If you're interested, you can look that up, or you can ask, you know, Devin questions or stuff like that. And also these RGB values. RGB is just this way of representing color by different values of red, greens, and blues. And so you can take a look at that. As well, we have stuff like fill color. Okay, so if I have some shape, I can use my turtle dot fill color here in order to say, what do I want to fill my shape with? So for example, blue. And let's draw my box again. Okay, so for I in range 4, and I'll go my turtle dot forward 100, and then I want to do my turtle dot right 90. Okay, and I run my code here. I have my box, right? But what I need to do in order to make sure that I sorry, so that I fill it is I need to use a begin fill and an end fill. Okay, so here's my fill color. I'm going to use my turtle dot begin fill and my turtle dot end fill. And that way we know to begin and fill the color. So there's my lime green square that's filled in with this blue color. As well, there's stuff like, you know, control items like changing the speed of my turtle so my turtle goes a little bit slower. So my turtle dot speed. Okay, when we're talking about speed, like 0 is the fastest if you don't want to wait around for your turtle to draw, but you can play around with different numbers to have it draw faster and slower on the screen. And then as well, there's some helpful commands like, you know, putting your pen up and pen down. So for example, we can do stuff like my turtle dot pen up. This will lift the pen up, and then I can move around the screen. And then when I'm done, I can do my turtle dot pen down like this in order to place the pen down on the screen. So there's lots of different things that we can do. And that's just kind of a example from there. Okay. So putting all that stuff together, there's lots of different ways in which we can change color, fill color, do all that kind of good stuff. And then as well, control the pen. There's even stuff like changing the line thickness if you really want to. For the sake of time, I'll you know, let you play around with it and look things up. And if you get stuck, you can come back to us. Okay. Looks like we're out of time, so I'm gonna save this piece for the next time about drawing circles. But we were almost done, and I think that you could definitely do some sort of practice exercise like this if you want to before tomorrow in order to test yourself to see if you can draw those shapes. So think about you know, for loops and the ways in which you can sort of turn and go straight in order to create these different angles. You can do something like this. And then after we learn about drawing some circles, we'll be able to do something like this tomorrow. Okay? All right. So before we end the session, I think there's a couple questions. Jaden, you have a question?
What if you need the
Yes.
speed to 99 and basically make it 100 loops with a long line? What will happen?
I'll let you play around with the speed number to show you, and then we can talk around about it tomorrow. Okay. Jean, do you have a question
Can I see your code?
for drawing the circle?
No, the other one.
This one?
No, the one you wrote.
Oh, like this.
Yes. Okay, thank you.
You're welcome. All right. All right. So we've already reached our limited time, so I'm gonna stop sharing my screen. And Charlie, is there any final words that you would like to share with the students?
Yes, I like to say thank you so much, Teacher Brandon. I think that's yeah, each time I watch your teaching, it's a fun. So also students, this is the first part of our teaching program. So tomorrow, the same time, we have a second part. Mostly we will teach you how to do animations, how to do a project. Yeah, see you tomorrow the same time for the next 2 hours class. Yeah, thank you.
Okay, thanks. Bye.
Thank you all. See you tomorrow.
See you.
Bye bye.